Hi everyone, my name is Richardson Alexan, and on behalf of the co-authors Ali, Ayman, Salah, and Wim, I will be presenting our work entitled On the Identification of Third-Party Library Usage Pattern for Android Applications. Mobile applications are an integral part of our everyday life. We use them everywhere. Android applications have a great expansion. We use Android applications in various domains. On the Google Play Store, the official app store for Android, there's more than 3.04 million Android apps. In order to develop an Android application, developers use development environment like Android Studio, IntelliJ, Eclipse. We need a programming language to develop this application. We can use Java, C Sharp, and so on. In the development work, the developer can reuse existing code, developer make use of existing third-party library, and also use existing API. Using third-party library presents some advantages. The code are already implemented and tested, which inspire a certain level of confidence in the use of libraries. It makes easy to add new features since in a library you can have several basic functions like online payment, chat service, calendar management, and authentication. Cost reduction, the programming time is reduced. There is a lot of free open source libraries, and the maintainability is because of the documentation and the experience of developers with libraries. Our motivation based on the exponential growth of directory that contain libraries. Identify a library appropriate to our need is difficult. We can find ourselves in the situation where we have many options, but a choice is difficult. Most of the existing work use machine learning to find relevant recommendation of third-party library. They have their limitation. They provide a long list of libraries. There is no support to select libraries. Developers are typically lazy and unlikely to go for a long list of recommended libraries. With Scandoid, to address this problem, we combine machine learning plus a user-friendly visualization. Scandoid has take as input first a query from the developer who is looking for a new library recommendation based on a current used library in his Android app. And second, a data set in the form of third-party library usage record from a set of available app on Google Play Store. As output, the Scandoid return a set of library usage patterns that can be relevant to current app. The dataset contains a set of Android apps and the library that are used by this app. This Android app represents the client application. Then the dependency information is encoded in the form of usage vector. We use hierarchical clustering technique based on DBScan to group the libraries that are most frequently used together by client app. One of the most important parameters that we use is the epsilon parameters that determine the distance between 2 points, for us, the similarity between libraries. For having multi-level of representation, we relax the value of epsilon from 0 to 1 step by step. All libraries that have no consistent usage for the client apps are insulated and considered as noisy data. We use the following USIM formula to compute the distance between 2 points. For visualization, we use D2GS. Thus, we make a multi-level representation of pattern of library. With D2GS, we can zoom the levels, determine the similarity level depending on the number of layers. We evaluate our work on two factors: pattern usage cohesion, pattern generalizability. We formulate the research question of our study as follows. How the input parameter can affect the cohesion of the detected pattern? To what extent are the detected library usage patterns generalizable compared to other client applications? For evaluation of our tool, we use the dataset of application 14,233 application library, 1,000 Android application, 1,458 third-party library. The dataset was collected using Libroad, a library detection tool for Android applications. We observe from the figure the variation of direct has a direct impact on the cohesion of the detected usage pattern. Liscandoid can reach a high peak score of 1 with low value of maxillon. From the result obtained from the experiment, we observe that Lipscandoid is able to identify patterns with a high level of cohesion and stable. With a max epsilon value equal to 0.7, Lipscandoid reach a peak value equal to 0.53, which implied that more than 50% of libraries are used together with a large peak value. The obtained result for both training and validation dataset, we notice in both contexts we obtain a high peak score. In the context of validation, on average, the pattern have a peak value equal to 0.86. In the training context, peak reach an average the value of 0.9. We observe a low deviation. This result indicates that the library usage pattern detected by our approach are relatively stable when tested on unseen data, then on other unknown client Android apps. Overall, the obtained result indicate that all detected usage patterns achieved by Lipscandoid retain their informative criteria when tested on new data. This helps developers identify relevant library usage patterns based on their used library in their app. This is the user interface of Scandoid. On the left, we have the parameters panel. We can use the slide bar to modify the value of the parameters, max epsilon, mean point, step epsilon. On the right, we have the search bar for searching recommendation compared to specific library. We can use a text file that contains a list of used library as input for getting recommendation. We can click on the pattern to zoom for more details. We have released our tool publicly available on GitHub. We have also the dataset and all the artifacts available in our application package. We will have a quick demonstration of Liscandoid. This is the interface of Liscandoid. In the case of a developer that wants to have a recommendation for libraries, for app, the developer already use App Compact. You can see the library App Compact. This is the library for graphical. So the developer search other library that use with App Compact. If we click on this pattern, we can see the recommendation, the first recommendation. So we have swipe fresh layout. So fresh layout allow to manage view. It used to refreshing view and managing progress bar. So the developer was searching for a library to to see the gesture in a specific view, to manage the cursor in a specific view. So we see the recommendation that we have is relevant, and if we change the number of points to 0.2, we can see another presentation. And if we look for the same library, you can see App Compact over there, and the recommendation, and we can see here the same swipe swipe refresh layout that appear again. That's the library that we talk about later. Okay, this is the view, and we can see the other level that we can zoom in, zoom out for seeing the recommendation and make a choice easily with a friendly interface and visualization. Thank you for your attention. We are ready for your question. For more information, you can contact one of the authors of this paper. Thank you.